Incubation Unit located and hosted at IIIT Kottayam. Today's speaker will be Dr. Shajulin Benedict, our director to IKE, and he is having a PhD and post PhD from Germany. He is a senior member for IEEE. And over to you, sir.
Yeah. Good morning to one and all here. And let me also thank the team for organizing this activity. I believe that most of you are either doing a PhD or some are just in MTech level. Of course, when I took the statistics, I found that around 85% of the attendees are PhD candidates, like they are pursuing PhD, right? Or at least 2-3 are from 2-3 people are have completed PhD. Yes. Okay. So today, let me start the PPT. 1 minute. I hope it's visible to you, right? Is it visible to you all?
Yes, sir.
Okay, very good. So uh, the topic what we will be covering today is IoT related research and effective article writing. Before I move further, I would like to get a very short synopsis of real understanding of what we really expect from the webinar. If some sort of questions are there, you could type in the chat box. Okay, I am just trying to find out if you have any questions, you could simply type here in the chat box. Okay. So the lecture today will have two parts basically. One is specific to what is IoT research, okay, and the topic related to IoT research and IoT subdomains and so on. The current trends relevant to that also will be covered here. And the second part will be relating to writing research articles. So this will be the second part. Okay. So the first part may be having lots of I will start from the base of IoT, and then I shall provide some synopsis of what kind of research topics could be taken forward by the researchers. Okay, and in the second part, I will show few writing methodologies and what procedures we should follow while we write an article. Okay. So I hope this is clear to you all, right? Could you please type yes or no if in the chat box, so that I can understand whether you are in sync with what I wanted to explain. Right? Okay. So, yes, as it was mentioned, I completed the PhD from AKC Research Center, Anna University, Chennai, then postdoctoral as well as guest professorship at Technical University, Munich, and then I am pursuing few research projects as well as other projects, including this incubation process. Okay, and I have also completed a few projects related to DST as well as Indo-German as well as Indo-Austrian related projects. Okay, just a very brief synopsis of what I have done so far. And this will be the agenda. Okay. If you ever have any some sort of questions or something, you please ping me or type in the chat box so that I can go through it. So the first part will be the basics of Internet of Things, because I have checked the 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 audience who are here, and few are also from mechanical background. I don't know. Maybe you are towards intelligent transportation systems or something like that, or you may be interested to incorporate some sensors into the systems. Um, of course, many of you are working in the IoT domain, so maybe that will be throw some lights on what kind of research you could pursue in this particular field. Okay, fine. So, talking about Internet of Things, okay, as um, you all would have heard about the term, as well as you would have come across this definition of Internet of Things. Okay, uh, Internet of Things basically talks about extended things. Okay, extended Internet to things. So this means it is a sort of future internet. Okay, it's a sort of future internet where you have the ability to directly connect or directly talk to some of the things. So since we all know it's an it's an extension of internet. So earlier, we all know that internet means it is for computing machines or for mobile devices. We all are familiar with that part, right? But now we say that it has to be extended right to the things. Okay, the things could be of any objects. It could be like your table, or it could be a fan. It could be some other devices that are connected with you, or whether it is nearer to you. So by providing the internet, by providing such kind of connectivity to those kind of devices or those kind of things, is going to create a change. It is going to provide some sort of um, upliftment in the society, as well as to you personally, as well as to the people around, right? So it's a sort of future internet. Okay, the future internet, in the sense, like so far we were just providing computation, the internet just for the computation devices, but now to all the things that are over there, right? Billions of computing devices are expected to be connected. Billions of personal devices may get connected. Trillions of sensors may get connected. Okay, so this means you definitely can imagine that lot of connectivity, lot of uh, things are getting connected. So what is the advantage basically by connecting that many devices, that many objects, as well as that many things put together, directly getting access to that? Okay, this basically creates some sort of innovations. Okay, it offers more flexibility for the entrepreneur, as well as researcher to uh, uh, think of in a different direction. Okay, like for example, if you are just connecting to a server or to a mobile device, you could just do some sort of programming, right? Or you could do some web-based applications or something like that. But when you say we want to connect to the things, right, to the objects over there, it is definitely going to create more value to the innovations that could happen in the future, right? In fact, IoT provides a very smarter society. It enables a smarter society Like for example, in 2050s, it is expected that the robots will lead the life. Okay, this means you yourself will get some robot, okay, and you can you really can work with the robots. You can entertain yourself with the robots, okay, and so on, so on and so on. We all know that we could not recollect many of our past histories as well as past events. I'm sure we could not remember many of our past activities. But if you uh, provide a sort of helmet, which is an upcoming one, okay, and this particular helmet will try to fetch the information that you already know are uh, providing in your brain, so that image as well as the information is just fetched in the helmet, and it is kept in the chip, a memory chip, and then after a few years you just load this memory chip, and then you start to act based on that. Of course, this is just a fantasy now, but this is a sort of research which people are trying to solve as well as to work on, okay, especially to uh, help some sort of patients who have some problems, issues, and so on, to act by their own. Got it? So, in very simple form, the human life, the human life becomes much smarter with the inclusion of this, the technology called Internet of Things. Similarly, you get knowledge-driven society. The society becomes much knowledgeable. Okay. For example, you go to a mall, you will be reminded, okay, through your mobile phone, that you want to purchase certain products. Okay. You will be reminded saying that your budget, your bank budget is this much, and you have sufficient money. Now, if you purchase a particular product from this particular mall, the price will be so and so. By this, you will have you could easily save at least like 5,000 rupees, 10,000 rupees. That kind of comparison, okay, will be provided to you. So see how effective the Internet of Things could function in the near future. Go to a farm, okay. Imagine that most of us are working in some other locations. Okay, maybe your house, your native house, and your cultivation and something is happening, and maybe your parents or your family is taking care of that, and you are somewhere very far away. And in that case, you could get the yield values, or you could get what would be the productive situation at your farm, or at your agricultural paddy field or something like that. So, knowledge-driven society. You get knowledge-driven society, and because of this, you are very productive, and you could easily earn, or you could easily improve your lifestyle in the near future. The cognition-enabled machines will become much common. Okay. This means the machines, right? The things, the objects that are what I have told. I am extending the internet. So these kind of devices, these kind of machines could talk each other. Okay. So the first machine will say, "I have completed my task." Now the next machine will say, "Okay, I am ready to receive the next task." Likewise, and the productivity of the entire system will be very, very high. So, since the machines are becoming much cognitive, the incorporation of intelligence to the systems, the servers, the sensors, or the network becomes much intelligent. Definitely, in the near future, the productivity is also very high. So in very short form, we could say that the devices, not only from home, it could also be offices, hotels, coffee houses, right? Airports, gyms, hospital, and so on, so forth. Everything will get connected. Okay. So by this connectivity, the future is going to be very, very enlightening. Because of this, you can easily imagine the best scope for the society. Got it? So, Internet of Things basically says that it is the extension of Internet. According to the definition, according to Gartner Research 2, it is defined as the IoT is defined as the network of physical objects that contain embedded technology to communicate and sense, interact with their internal states. Also, the Wikipedia, it's very clearly it's mentioning that the extension of Internet connectivity into physical devices as well as everyday objects that you see in the um, life. Okay, from the home, from your office, or from wherever, all these things, all these objects are about to get connected. Okay, what is the trend of IoT in India? Let us think in both perspectives, like research perspective as well as product perspective. You could see that the number of publications are drastically increasing, and of course you could see into 2020 it's very high. 2021 is still increasing. Okay, and it will still reach this level at the end of 2021 for sure, right? So yeah, 2021 you could see that the number of publications with respect to the IoT field is very, very high. Okay, this shows the interest of the people moving towards this IoT domain is very high. Okay, IoT is associated with several other technologies. So you combine IoT with something else for your purpose. You see some problems in your society, and you try to figure out what kind of problem could be addressed with the help of the sensors as well as technologies. Then you bring out a new technology, the new product out of that, right? So it's very clear from the trend of IoT that even the patents, right? See here, the patent filing is also shown here, and you could see like continuous patent filing is happening in the field of IoT. Just with the search keyword of IoT, you could see this. And the investors, of course, this is the old one and this is the new one. You could see how the investors have funded or ready to fund for this particular technology. Okay. In fact, IoT, while investing, they have invested in several subfields too, like manufacturing sector, transport, logistics sector, automotive sector, healthcare sector, retail sector, agriculture, and so on. Agriculture, one of the example would be finding the yield, right? Yield, or you want to find the reap of the ripeness of particular fruits. Okay, see, one example would be like this. You have a mango tree or bunch of such mango trees in your farm. Okay, in your agricultural farm, let us say. So in this, you want to see how many mangoes are ripe. Of course, as a person, it will be very difficult to check where the mango, at least where the mangoes are placed. Especially think about some old people, right? Your let us say your father or grandfather or someone very old who goes to the field and he wants to see whether the mango is ripe, how many mangoes are ripe, right? It will be very difficult to check one after the other. right? But if some drones are there, which captures the images and does some sort of processing, and based on that, if it is able to show, pinpoint, like this is these many number of mangoes are ripe, and we need to pluck these many number of mangoes, and the price or the yield amount that we would get out of this particular field would be these many amount, right? If that kind of system is there, it is very very useful to us. So likewise, there are several innovations, several uh, different products that are upcoming in the society. Okay. So agriculture is one field, retail, healthcare. Healthcare is also booming these days with the help of IoT. I will be discussing few of those uh, applications related to that. Automotive, likewise, like self-driving cars. Many also e-vehicles. E-vehicles are also becoming more popular. Transportation as well as logistics, like should we transport the waste from one city to another city? Should we know, economically send only one vehicle or multiple vehicle to pick up the waste, right? So all these are guided these days with the help of IoT, and as well as the decision making. It's also automated with the help of IoT. So similarly, in the sector called manufacturing, right? Like let us say car manufacturing or whatever. Um, no, we could earlier and all. If you see, um, uh, purchasing the raw material sometimes could take time, and suddenly some people would forget to purchase certain raw materials, especially some of the startups who are working on this in any fields. Okay, you people, when you do some mass productions, you forget some of the procurement of some of the raw materials, right? But if you are associating things with IoT, right, the sensors connected with applications will be able to easily figure out what kind of solutions could be, what kind of solutions, what kind of raw materials, what kind of um, machinery may be required, and so on. So this comes under this manufacturing sector, and of course the funding is very very high, and it is also expected to grow very high in the near future. Of course, China is also investing a lot in IoT domain. If you see the global scenario of IoT, smart cities, okay, connected industries, connected building, connected car, smart energy, connected health, smart supply chain, smart agriculture, smart retail, all are having certain growth pace. Okay, smart cities, if you see, in India we have a sanctioned, like 101 smart cities. Of course, it is not still at the final level of what a smart city should expect, right? What is the difference really between the city, a normal city, as well as smart city? If you see, um, cities will have infrastructures, right? The infrastructure could be, the infrastructure could be like malls, um, sufficient banks, okay, bridges, metro trains, certain number of theaters, and so on. This is the normal city infrastructure. Okay, cities will city like Chennai or Kochi or Trivandrum and so on. They all normally will have these kind of infrastructures. But what is the difference compared to cities, normal cities as well as smart cities? Of course, Kochi and Trivandrum is now elevated to smart city, although the uh, complete vision of what smart city should become is not yet complete, right? So, what is the real difference if you see in smart cities is the residents of people living in such cities should get revenue. Okay, should get additional revenue. It's not just a revenue; they should get additional revenue as well as high comfort. Okay, so this means the people living in smart cities, um, all the bank details, everything will be connected to the city authorities too, of course, the banks, right? And then they will be pinpointed with appropriate additional job opportunities. They will be pinpointed with a matching skill set requirements. Okay, so in addition to what they normally earn, they will be hindered with certain uh, uh, financial benefits. Okay, by doing so, by accepting those financial benefits, they could easily get the profit, or they could easily get additional revenues and so on. And even though they don't get job, okay, even though they are not or they are dropped out from a particular company or something, they still will get money. Okay, as like Warren Buffett normally used to say that while sleeping you should earn. Okay, so how this is possible? You will be investing in several things, or you will be carefully offering your skill sets, mindsets to develop something. So this means during your absence, still the money that has to come to you will always come, right? So this kind of approach will be possible through smart cities. Okay, so you will be working, okay, little, but the revenue possibilities that you could gain from the smart cities will be typically high. Of course, this is what expected in smart cities. Apart from the normal living, okay, apart from the normal comforts living that you can gain, like comforts in the sense, like pollution-free environment. Of course, people have to work on that, right? Smart cities should work on that. Is it really realizable at the present moment? Of course, it is hard to do that, right? At the present moment, especially in India, especially in cities like Delhi, it is not really possible, right? The pollution is very high. So some sort of automated system should be there. IoT enabled system should be there, which will figure out how to solve such kind of social related problems, and to keep the people living in the smart cities with high comfort. So also, if you see the highest IoT related patents from the industries, you could easily see like Samsung has filed a lot of patents, Qualcomm and others are following in this particular patenting process. And also the platforms, which platforms are offering such kind of IoT. And if you notice this, um, IoT from Microsoft is very well utilized, followed by Google Cloud IoT, and then AWS IoT, and then you could see Cisco, Watson, and so on. And there are certain number of a good number of IoT platforms that enabled some people to immediately start with developing some IoT related solutions. Okay, and if you see most of these platforms, there is one similarity which we can notice, right? Uh, the one similarity which you can figure out here is Microsoft Azure, Google Cloud, okay, Amazon AWS. All these are typically cloud based cloud based, right? You can easily notice that, right? So if you see most of the cloud providers, okay, cloud infrastructure providers, they have come up with the infrastructure for supporting IoT. Okay, of course, in any kind of IoT application, you could connect them to cloud. Okay, why there is a need for cloud? Of course, we will be discussing this too in the later stage, but in a short form, IoT needs cloud for analytics purposes. Okay, so Microsoft Azure, Google Cloud, Amazon, and so on, they are all basically cloud providers. Earlier, they were providing infrastructures, they were providing platforms as well as software as services, and now they are willing to offer IoT. So IoT is support. So this means your things, your objects, your devices, when connected to such platforms, will be easily accessible, and you can easily develop some IoT related application, like for example, finding out the average temperature, or finding out monitoring the health status, or monitoring the humidity of a particular location, and all these things. Got it? So IoT platforms are used, and you can see how many percentage people have used in the past. Okay, for wearable related applications and so on, most of the applications are cloud related. Okay, so so far I have discussed about the trends, and as well as I have told what IoT mean. Okay, now we are moving to the next part, that is IoT domains as well as subsets. Okay, I am unable to make some drawings here. Somehow the tool is not supporting him. Okay, I hope you can easily understand what IoT mean. It is just a extension of internet. So you are providing internet to certain objects, okay, certain things, and you can develop some IoT applications. These IoT applications are responsible to um, connect them, and these applications are responsible to provide the insights of entire connected things as well as objects, and make the system productive, or make some innovations, which is much possible through this IoT. Got it? So now let us go to the next part, that is IoT domains as well as subsets. There are few subsets of IoT domains. Okay, um, uh, the the way how the Internet of Things is used or utilized, IoT could be subdivided into 5 different categories. Okay, one is industrial Internet of Things. Second one is consumer Internet of Things. Third one is social Internet of Things. Fourth one, semantic Internet of Things. Fifth one is productization Internet of Things. Industrial Internet of Things talks about industries. Okay, the sensors as well as devices that are providing some additional support, which improves the processes for executing, that improves the processes that are involved in the industries. Okay, is called industrial IoT. Industrial IoT is basically, it applies embedded intelligence as well as the network connectivity of all these IoT devices. As I have told, it is to improve the system, improve the product. Okay. So it is a kind of smart product design principle. Okay. Typically, data are collected from all the sensors or devices that are connected, and all these connected devices, all these connected sensors are then finally um, used to provide some improvement in the existing process. Okay, Let us take some examples, like for example, a car manufacturing sector, and imagine that cars are manufactured in different plants of industries. So if imagine that the body part of the car is manufactured in one location, and then painting and finishing happens in another location, and so on. Um, if human or human people or humans are involved in this car manufacturing sector, um, once after completing a particular process, they have to inform the other person, and then the other person from the other plant has to start the next process based on the product that is available from the previous process. Okay. So the time that it takes to make the product will be very, very high. Rather, if sensor enabled some machines are there, and if these machines communicate to the next machine, okay, if this machine talk to the next machine much easily, then you can do a lot of things. Like the manpower can be completely reduced, maybe. Okay, um, or your the machines, because it is making fast decisions too. Um, the machines could make the things much faster, and development of the car manufacturing is much faster. But getting the raw material from the different appropriate industries could be much faster. All are automated because machines are talking to other machines, right? Similarly, if you take 3D printing companies, hope many of you know 3D printing, right? It is different from normal printers, 2D printers. Of course, 2D printers we all know, like if a document is given, you will get a print, right? You get the print in the paper form. But if it is 3D printing, you get the print of a 3D model, right? 3D object, right? So, how many of you have 3D printers at your institutes? Can you please type in the chat box? How many of you have 3D printers at your institutes? No one? No one is having 3D printers at your institute? Okay, so typically a 3D printer will look like, yeah, Mr. Mayank, they have a 3D printer, right? So a 3D printer is just a machine which looks like a normal, like a printer, but with a space where you can print the 3D objects. Okay, 3D means you can print like a mouse. Okay, you can print like some 3D object. Okay, which is very useful for prototyping, rapid prototyping, and so on, right? So these days, people are also using 3D printers to print the, no, to print the entire building. Okay. Say, for example, you want to construct the entire building, or maybe a portion of the building, right? 3D printers are used to using some appropriate, materials. Okay. Similarly, if you want to print a particular toy, okay, so which you have something in your mind, you want to print them, you can print it. Okay, you imagine that you have a bottle. Normally, bottle looks of a particular shape. Okay, but if you think that bottle should not be of this shape, it should be of something of new shape. Okay, then you can design that new shape, and you can provide that design to the 3D printer, and then this 3D printer will give the exact style, exact shape of what you expected, right? Why this is important for rapid prototyping is because you have something in your mind. Whatever you have done as research at the end has to become like a product. Then only it is useful to the society. So you created something and you developed something, and now you want that research, some idea to become like a product, right? So that kind of design, as you can make it in a 3D shape, okay, with some softwares including like CAD or Tinkercad or something like that. And once when you complete that, you can provide that to this 3D printers, and it can print the object, right, as like what you would expect, right? So 3D printing companies are improving in this subdomain of IoT, which is industrial IoT, right? Smart buildings. See, you cannot typically construct smart buildings very often. You can also test that using 3D printers. That is also possible. Similarly, like creating smart buildings or establishing smart buildings in using 3D printers. All these are industrial related IoT, where fundamentally what we want to really understand here is the sensors and the sensor connected devices will communicate to the next device, okay, and make the processes much easily. So that it is typically called like industry 4.0. Okay, this is the term based on Germany, but in USA they call it as industrial internet. Okay, what is this industry 4.0? Industry 4.0 is given basically for this versioning, okay, versions of industries. Industry 1.0, Industry 2.0, Industry 3.0, Industry 4.0. Okay. Likewise, people have started to frame several versions in all other sectors too. Okay, like you can even see here like blockchain 1.0, blockchain 2.0, and so on. And you could also see healthcare 1.0, healthcare 2.0, 3.0, and so on. So this becomes a fashion these days in the research field too, right? Uh, Industry 4.0 is typically the revolution based on this. And if you see the first revolution, it was based on water and the steam power engines. Okay, the second revolution was based on electrical engines, power revolutionized, as well as productions like, for example, using belt conveyors, which was powered by electricity. So this is the next revolution, which created the drastic change in the way how the processes were done in industries. Okay. Third one was electronics as well as IT, like microcontrollers. If you see past industries, very recent, like the 80s, 1980s, and this period, you could notice that most of the industries will had developed microcontrollers, and some even for communications they used emails and so on, right? And of course, manual intervention was there. Manual people were there to sit and evaluate and take the decisions and so on, right? So some uh, software enabled systems, okay, that was developed. Later, for Industry 4.0. Now, the people are also discussing about Industry 5.0, where a lot of intelligence, artificial intelligence, and so on will be incorporated into the industry processes. So, ultimately, the revolution is meant for change that happened in the processes, underlying processes of industries. Okay, since Industry 4.0 was connected with IoT. Okay, Siemens was responsible for coining this term too, and they have identified the lots of issues that were there with industries, and based on the survey that were carried out with multiple manufacturers as well as industrialists, and based on that, they derived this Industry 4.0 concept. Of course, if you want to develop something, right? If you want to design a new industry too, we all do this analysis, right? Market analysis, and we see what is the perspective of different customers, and if the customers are happy, if a large sector of people are willing to have such kind of things, only then we move forward. Correct. So likewise. IoT enabled systems were really a demand, and the problem was so huge, and based on that only they went forward for the next revolution. Problems are everywhere, right? If you see problems, uh, normally people are used to that problems, correct? Uh, we are also used to such kind of problems, and we don't think that, or we don't realize that it is a problem, correct? uh, Inventions will not come unless we think out of the box. People normally say this, right? Inventions or new discovery is based on the people who think out of the box, right? So problems are everywhere. We all have problems. We are living with the problems. We think that, okay, this is how it has to be done. So we are not using really the right brain compared to left brain. It is told normally, left brain is meant for analytics and reasoning and so on, but right brain is mainly meant for critical thinking, right? So if we are always thinking of the existing things, okay, like everyone told like this, so I'm also doing like this. Okay, so then we are using the left brain. Whereas if you think out of the box, right? So why it has to be like this? Okay, why can't we do it in another fashion to solve uh, this as a problem? Okay, um, first of all, we don't see that as a problem. That is the main problem. Okay, we don't see something as a problem. See, you are reading a lot of research papers. We don't see something as a problem, right? That is a problem actually. We should think in out of the box perspective so that we can see the problem. That is one of the first and important criteria for getting a new idea as well as new invention, which people normally lack. Okay? People keep on reading, people keep on watching everything, people walk around, they see everything and they don't see the problem. They don't notify the problem, right? So first and foremost is identifying the problem, right? So that brings the new birth or new evolution to the developments. Let us take some examples like in industrial IoT. Let us take some examples like predictive maintenance. Okay, say let us take imagine that you have a very good car. Let us say uh, BMW or some very expensive cars are there, and only certain workshops are available for you to do the maintenance. Okay, imagine like that. Imagine a situation like this. Okay, if you want to replace a tire, which normally what will you do? You will have to go to the workshop, and then the workshop has to say, oh, okay, this particular part is not available. You will have to wait. Okay, but if you uh, have a sensor attached to the tire, and if this tire is directly communicating to the workshop or the concerned people. Okay, let us say it is directly communicating to workshop, and in workshop there is another sensor module, okay, which is collecting this information, and this particular module is making another kind of connection to multiple manufacturers, tire manufacturers across the globe. And then the tire manufacturers, say for example, if it is MRF or if it is some other tires, okay, there are several new tires manufacturers these days, right? So it has, if the workshop is that sensor module is directly sending the communication to all these tire manufacturers, and the tire manufacturers are figuring out. Again, it is not personal. Okay, some sensor modules are sensor modules attached with some intelligence or analytics or networking components. We will talk about this. Okay, if that is making some decision, and if it is saying that okay, I can offer it offer a tire at say 20,000 or 15,000 rupees. And another tire manufacturer from China is saying that I can provide this for 5,000 rupees. Likewise, multiple suggestions come from different tire manufacturers, and at the end, the workshop sensor module is again making another kind of analysis. Okay, and based on that, finally, once when you are notified that you have to now go to the workshop, okay, that too the tire could do, right? Tire could inform you, and based on that you can drive to the workshop, and immediately you get the tire. Why? Because, and that too, this particular tire, which you didn't notice it, okay, your sensor module is informing you that the tire has to be replaced. Your sensor module is informing the workshop. That particular workshop module is connecting to multiple tire manufacturers, and it is giving you the bargained price at very cheap rate. Okay, it is sufficient for you to make the decision, or your sensor application to make some decisions based on the availability of the budget, as well as based on several other parameters that you input into it, right? These kind of solutions are really welcome in the society. Of course, it doesn't look like a big problem for you at the moment. You may think that okay, tire has created a problem. Okay, now we want to purchase a new tire, right? But you think that it is not a problem, right? It's not a problem at all. You have to do that. But if you think in the other angle, now this becomes like a problem, and you could easily get a solution, right? IoT can offer several solutions in that perspective. Okay, how the customers are benefited? Customers get very customized solutions, right? Otherwise, if he's going at the last minute to the workshop, and with the workshop could easily say that the particular tire, the particular number, or the particular product number of the tire number is not available with them. Okay, and they may force you to wait for 10-20 days, right? So thus customers get things much faster, and not only that, they are getting the cheaper price, comparatively cheaper price. Okay. Similarly, how industries are benefited? Industries are getting mass production. Okay. Likewise, like how our tire communicated to the car manufacturer or tire manufacturer, okay, maybe located in China or maybe located in some part of Delhi or somewhere. The manufacturer is getting similar queries from multiple people, and the deal is already made by the machines themselves, and now the industries could make the production automatically by purchasing the raw materials and so on, right? So this kind of life cycle of manufacturing the product could be imagined much easily with the help of this Industry 4.0 concept. IoT for e-vehicles, which is also connected with the industries, is very, very becoming much popular, and a lot of research are particularly going on in India. Okay, not only in India, it is everywhere, but more specifically in India also. Why? Because we are scarce of power, right? I mean, which power? What I say is petrol as well as diesel. We always, ending up with a lot of cost. Every day there is a hike in price, right? Daily we could notice this. E-vehicle could be one alternative, could become one alternative, and there are lot many research going on to find out the best battery opportunities too. Once if it becomes successful, you are going to replace the petrol as well as diesel based machines, cars or vehicles. Okay, what kind of research people are working on in this IoT e-vehicle domain? If you see, still machine to machine communications becomes much popular. Okay, like you have multiple charging stations, and these charging stations um, could be located in some particular places. How effectively the battery could communicate with the charging station? Okay, you could imagine that the charging stations might not be available in all the locations, all the places. It could become very rare. Okay, and how effectively the battery will communicate. Okay, battery will communicate in the sense the machine, along with the sensing module that is there in the batteries, will communicate with the charging stations. Okay, and it will try to identify the best possible uh, charging station for its charge. Similarly, how effectively sensors could be used for monitoring the battery lifetime. Okay, um, seeing the bulging of battery. So the sensing module could be attached so that you see the variation in that, and you can take up the decision that no, it is the lifetime is about to end. Okay, or there are certain sensors which you could embody into it, and you can check or you can monitor the battery. Similarly, IoT and blockchains could be involved for charging. Okay, so for example, like each EV vehicle owner could be provided this many charging capacity, and are they really using? Are they going to overspend the charge that is allotted to them? Okay. These are all different research perspectives which you can think of in the IoT for e-vehicle field, e-vehicle domain. It is still one of the industrial IoT. Why? Because the processes are involved where the sensors are used for the different industries. Okay, different industries like car industries, vehicle industry, transportation industries, and so on. Okay. Similarly, e-mobility with the sharing concepts, like uh, people are working on shared mobility too. Okay, like how many people could be accommodated, okay, in a vehicle, right? Let it be e-vehicle, because e-vehicles could not be overloaded. So how many number of passengers could be placed in the vehicle? Okay, so this is also a kind of research people are working on. How many of you are working in transportation domain in IoT, like e-vehicle or something like that, or some topic relevant to industries, industry related IoT? If you could type in the chat box, that it would be fine. or no, you could type what kind of application that you prefer to develop. Maybe you can think a while during the presentation too. You can type in the chat box like what kind of application that you are currently working on, what kind of research currently you are working on, so that I can provide more emphasis to research aspect. Okay. Okay, so this is about the e-vehicles, and of course there are several technologies connected with this. Say, for example, big data is also involved. Robots are involved. Simulation technologies are involved. Um, Horizontal as well as vertical integration of resources. Okay, Internet of Things is one among in IoT. IIoT, that is industrial IoT, cyber security, cloud security, cloud computing, additive manufacturing, okay, augmented reality, and so on. These are all several building blocks that are connected or involved in industrial IoT. Okay. So the next subdomain is about um, consumer IoT. Okay, consumer IoT. So consumer IoT talks about the devices or the sensor objects that are more attached to the physical or personal purposes. Okay, like for example, your mobile phones, okay, or the sensors like rings. Okay, some sensors are even connected. Okay, like rings are also sometimes connected. Okay, connected to internet. That's what I'm coming to say. Okay, wearables. Okay, gadgets, fashion items, portables. Okay, uh, handheld objects, including mobile phones. Okay, instruments, voice assistants, utensils like your purse, wallets, and so on. These devices, particularly, they are consumer rated, right? So they are consumer purpose for that purpose. So they are, if they are connected, and if we are applying them for some application, we call this category as consumer IoT. Okay. So typically, like different variety of devices could be connected. Some may use Wi-Fi, some may use Bluetooth. Okay, some may use infrared rays, and so on, so on. So different communication medium is also involved, and the protocols that it uses may also differ. Different manufacturers too, like Apple will have their own type of product. Okay, Samsung, they have their own set of products. Oppo, they have their own set of products, and how that interoperability could be brought to achieve your IoT or to bring the purpose of IoT application. This is one kind of major research. Okay, say for example, um, studying the behavior of the human beings while using using such kind of consumer devices. Okay, some people can use wearables to even monitor the agricultural land. Okay, so far it is not available. Okay, most of the agriculture related applications, if you see, they are, I mean, let us say most of the smartwatches or most of the handheld devices that we have, they are only focusing on healthcare applications. If you notice, you can easily understand nowadays most of the watches are having healthcare sensing components, correct? Like recently, if you see, most of the watches are having capability to monitor temperature, it monitors humidity, it monitors ECG, it is monitoring heart rate, it is monitoring oxygen, pulse, and so on, so on. Okay, they are all focusing on healthcare applications, but there are no such wearables that focus on agriculture. Like for example, why can't we introduce a smartwatch for farmers? Okay, or to the owner of that land. Okay, let us say, see, I have a watch. I go to a farming land. Okay, and immediately the soil should speak to me. Okay, soil should talk to the watch. Okay, or the plants should talk to the watch. Got it? So this is not really available. How much should be the yield for me? I have to just touch the smartphone and I have to see, okay, today the yield should be in this particular mango grew, I should get, say, 10,000, 20,000 rupees. Okay, imagine that big farm. Okay, so, okay, then my estimation will be correct if no, I get this much. If my calculation according to the sensor application, if it says 10,000, and if I am getting less than that, okay, then I can easily question the relevant people. Got it? So such kind of applications are not there. Wearables are not there, right? Similarly, the wearables that for pursuing this analysis, right? For safer home. In most of the homes in Kerala, if you see, many people are living in abroad. Many people are living in abroad, and the people at home are left with maybe one or two people. Maybe parents or grandparents are living at home. How much security can you provide at home, right? And that too, if they are patients, like diabetic patients, how could you remotely monitor? How could your IoT system, medical system, remotely monitor that their people, okay, who are living in your home, old age people, or your grandparents who are living in home? We all know, typically, the diabetic patients are much sensitive, right? At night when they sleep, suddenly they drop, they easily get the sugar level could drop to 35 or 40, and suddenly it could increase to 140, 100, 300 or something like that. And at night it is much dangerous. There will be no sign of what to do, right? So sensor-enabled devices could be attached, maybe a watch, which will communicate to the concerned group of people, and they will get alert messages even at night times, maybe to the appropriate hospitals who will be functioning 24/7, and the uh, noticing some sort of anomalies, they could easily go and solve this, or I mean, they could save the life of the particular right? So wearable applications in healthcare is very useful. IoT plays a key role in such kind of applications. Okay. Uh, Most importantly, again, if you see some of the other applications, prevention of diseases and maintenance of health, okay, like fall detection is another one important application which a lot of products are evolving in the market. Okay, fall identification and prevention is recently I also watched one video where uh, grandparents are wearing a particular shirt. Okay, it is slightly not very heavy, slightly heavier, or it looks like a normal jacket. Okay, in abroad and all, if you see, jackets are slightly heavy, but it is good for cold situations. It is something like that, and they wear that, and also the jeans pant. Okay, uh, but once when they are about to fall, there are some sensors attached to it, and these sensors immediately activate some units and this particular shirts become like a ball, okay, airbag, and they simply fall down and nothing is going to happen to them. Okay, it is designed. It was the video very clearly showed that it is designed such that at a tilt of a certain angle, this airbag is opened, and they are protected from all sort of injuries like spinal cord injuries and so on, which normally happens at the age of 85, 90s, right? To protect that, IoT plays a key role there. It also suggests some sort of decision making processes, right, for even for cancer patients and chronic disease people. Normally you forget to take medicines after because chronic people, they have to take medicines regularly, and by mistake sometimes they consume two, sometimes they consume they forget to consume, right? So this kind of things could be easily detected in the edge itself. So I will talk about the edge cloud and the fog units, but you can imagine that. So there are some products where people have developed boxes, okay, medical kit box, where sensors are placed, which will sensors with actuators will be placed, and that will properly, carefully bring you and remind you whether you have taken the medicine or whether you have to take the medicine, and it will also notify the particular hospitals. Similarly, no physical exercises. It is no prevention is better than cure. So some industries, what they do, they work for a larger mass, not for the patients alone. Okay, patients are already patient, but prevention is better than cure. So um, there are some solutions for physical exercise related, like um, reminding them what kind of training you have to take and so on. Also, there are some textiles which warm up during chilly days. Okay, like for example, Polar Seal. They have designed some sensor-enabled textiles. Okay, it will you can just wear that on above your normal shirts, and you can go anywhere if it is cold, very cold outside, especially in countries like Canada or Europe and so on. It will automatically heat up. It will warm up the body. Okay. So thus patient monitoring, patient detection, okay, patient diagnostics, or patient curing. Uh, Stage after the stage, IoT plays the major role. Okay. Some of the devices, wearable devices that you could see in the market are like eyeglasses, earrings, clothing, gloves, and watches. Some are also skin attachable devices. Okay. One of the major research which we can see, or people are lively working on, is how to accommodate heterogeneous devices, okay, into one IoT platform or into one IoT application. Okay, so these are related to healthcare wearables. Also, there are, I am just pointing out some of the other examples here. Healthcare monitoring, are you monitoring remotely, or are you monitoring directly in a hospital and so on? Okay. Inside a hospital, so then it becomes direct, right? Remote monitoring is typically where hospitals or doctors will be somewhere outside, and they make remote monitoring, healthcare monitoring. Okay. Um, some of the parameters that they use are ECG, emotion, sleep, pressure, checking all these parameters. So monitoring as such is just monitor. It will just collect the value. That's it. So some IoT applications are just to collect the values. Okay. Um, like whether they are sleeping, whether they are having sufficient oxygen, whether the pulse rate is okay, right? Just collecting the values, okay? That is, if it is done, then we call healthcare monitoring. Of course, some people or doctors are involved to uh, cross-check that numbers, whatever numbers that we have received from the patient through the sensor network, and the doctors could see what to do, right? And it is very useful for some chronic disease related people. Health detection is another category where you go further, just not monitoring, but you are going further and you are trying to figure out what could be the anomaly. Okay, some edge devices are typically like some mobile phones. Mobile phones could act like edge too, and some edge devices are capable to detect some of the diseases. Like for example, your temperature increased to certain level, and then if the IoT application or the edge device is able to say that the temperature increased, okay, and it is constant for certain period of time, and then it will detect that you have fever. Okay, then that is detection, health detection. Okay, and health detection, a fever could be of for due to certain categories, or it could be because of several reasons. Okay, if you have walked so long and because of body tired, you could sometimes get fever. Okay, then health detection stage could just detect that there is a problem, right? You have a fever, but what kind of fever, what kind of problem do you have? So then it requires a certain inputs, right? For example, is it a tumor cancer, or is it something else? Or is it some pneumonia, or something like that, right? So this kind of information could be diagnosed, and for that the sensor devices could be used. Okay. Apart from diagnosis, prediction is also one among the approach which people are working on. Um, so, disease prediction, like certain technologies, including deep learning, right? Deep learning is becoming much popular because you have to just feed a certain number of rows of data, and the deep learning, like certain algorithms are available that will just do the analysis, and it would just predict what would be the reason, right? So disease prediction is also one of the research topic people are working on. And the treatment is the next level, okay, where IoT sensors and some robots are involved to make the treatment. Like for example, um, uh, of course, delivery of pregnant lady and so on. Of course, this is not much commonly applied so far, but at least to some extent, people are working on that research. So all these aspects are coming under consumer IoT. So we covered two domains, that is industrial IoT, and second one is consumer IoT. Now we are let me say that now we are moving forward to the next three topics, that is social IoT, semantic IoT, as well as productization IoT. Okay. Social IoT is about sensing the social informations, okay, social information, and providing some solution out of that, providing the gist out of that. Okay, there are so many social sites. Many people are using social medias, right? Like Facebook, Twitter, Google, right? LinkedIn, and so on, so on, right? So many social medias are available. Um, Without social media nowadays, it is very difficult to bring networking, right? We want networking to grow further, right? We all know that individually we cannot grow, or we could grow, but we cannot reach to the top. But only through the group, only through some particular network, we could move forward and achieve something what we could do, right? So social media is one form, because we are not much connected to direct people. Of course, there are limitations. We cannot find the appropriate skill set nearer to us, right? Say, if you're working in a university, you may find some number of people, but are they all working in one particular domain? No, right? If you're working in IoT, you should find some particular skill set people, IoT related people, who are scattered across the globe, right? Maybe if you are getting 100 people in IoT, and if you are grouping them together, and that network is going to help, right? The social media connected to that group or the network or that particular community will create a large momentum in your research, right? Likewise, a political person, right? A political person, um, if he wants to create a large mass of people, okay, he has to get associated with more number of people. That for that, social media will help, right? So in social media, many people will type many things, okay, and whether this information, whether the text that you have submitted is attractive, okay, whether it is attractive, whether it is creating uh, uh, some sort of different feeling to the people, okay. So for this, some sort of sentiment analysis, some sort of sensing of the textual data is required, okay. So the sensing of such kind of information, okay, and the IoT application, which is more relevant to this, and if it is categorizing such kind of information or sensing such kind of information, and providing the productivity, better productivity to the people, or is typically termed as social IoT, okay. Politicians definitely need this, because he could make some sentences, he could utter some sentences in the public, and this particular information, or the text, whether it has reached properly, whether certain communities are not comfortable with that, whether certain communities are attracting, receiving that text in a positive mode, okay. All these things has to be analyzed and sensed, and actions should be taken appropriately. Um, so likewise, like for example, I am giving a talk, and if I am making I would have, say, 500, 600 followers maybe, and if I make one post, and if it is if it is not well welcomed by the followers, then I should slightly change the text, so that I could bring back the interested people back to my community. So for all these things, sensing from the data is relevant, and therefore that kind of division is typically termed as social IoT. If it is more personalized or contextualized to particular person, okay, or to a particular people, then that kind of IoT is termed as semantic IoT. Typically, this semantic IoT is more similar to social IoT, but one difference which you can see here in semantic IoT is it uses technologies like OWL, okay, that ontologies and so on, and based on that, the sensing elements are captured, and the analysis or prediction or whatever is done um, based on that sensed value. So it is contextualized or personalized or tailor-made to particular problem or particular person or something like that. Okay. The last one is productization IoT, which is also more getting more vivid. Okay, that means it senses the feedback from the people um, for designing a particular product. Okay, so by say for example, there are certain solutions, certain solutions also like deep learning based solutions are available to check the emotions as well as behavior of people, right? Emotions in the sense like whether he is sad, whether he is happy, whether he is astonished to see something, right? Based on such kind of sensing on seeing a particular product or while designing a particular product, a new product is prototyped. Okay, a new product is designed. So this kind of rapid prototyping or productization um, based on the while customizing a particular product or particular design of a product is typically termed as productization IoT. Got it? So these are five different subdomains of IoT. I hope it's clear to you what are different topics of IoT that are available in the research field. Okay, and now we are moving to the IoT architectures, and I will talk about the serverless IoT architecture, which is also very recent one, which could be applied in any of the IoT subdomains or any of your problems that you could talk about. Okay, so very in a short form, if you see, let me say, IoT architecture, if you see, it is typically having only three major building blocks. Okay, only three major building blocks are available. One is sensor, second one is actuator, and in between you will have the network devices. Okay, um, so these are the three major building blocks. Okay, sensors. What it will do? Sensors typically are used to uh, check the parameters, temperature, lightning conditions, and so on. Okay, it is just to sense. What is the role of actuator is? It is to do some necessary actions. Okay, based on some sensing and so on, some sort of logic should be performed, and based on that logics, action should happen. So, as an IoT architecture typically will have only these three components: sensors, actuators, as well as network devices. So, if you see the architecture, sensors or actuators are at the end, okay, and you can see some sort of network devices too. Okay, when you talk about network devices, it could be edge, it could be fog, or it could be cloud. Okay, um, notably, cloud is always there. Okay, you can remove edge as well as fog in between, but you cannot remove cloud for any sensor related applications. Okay, because if you want to do some sort of analytics, if you want to perform some actions, okay, it is always required to have some scalable environment, scalable computing environment like cloud. Okay. Maybe for test purposes, you could use your own sensor, your own server, and you can do some test. But no, for making it a real application, it is advisable to use cloud. Of course, what is the difference between edge, fog, as well as cloud? We will talk about this in the future slide. Let us go one after the other. A general architecture sensor architecture will have IoT sensors as well as actuators as well as network devices. What is a sensor? Of course, it is a device which is going to detect a certain physical property. Maybe it is going to measure temperature, it is going to measure sound, it is going to measure something else, right? But one thing what you have to remember is it is just going to measure only one property at a time. Not at a time. If it is a sensor, temperature sensor, it is going to only measure one property, that is temperature property. Okay. If it is a sound sensor, it is going to measure only one property, which is called sound, right? Likewise, these are the features of sensors. It cannot measure multiple properties. You could have multiple sensors in one device. Okay, but a sensor is responsible to measure only one property. Okay, and yeah, these are some of the types of sensors. One is light sensor. As from the name itself, we can easily understand. Light is going to measure light intensity. Touch sensor is used for evaluating whether some touch happened. Humidity sensors, temperature sensor, likewise, force sensor, water flow sensor, position sensor, speed sensor, soil moisture sensor, ultrasonic sensor, sound sensor, chemical sensor, and so on. Like so many sensors are available in the market. If you take wearables, you can see accelerometers, gyrometers, global positioning system, heart rate sensors, speedometers, right? Accelerometer is just going to measure the acceleration forces. Gyroscope measures the angular rate, like the orientation to which angle it has moved. Global positioning system, it is used for checking the latitude, longitude of the particular places. Heart rate sensors are used to measure the heart rate, right? Pedometers, likewise. So each and every different sensors you could notice in the market. Actuators, in contrary, it is to make some actions, okay, to perform some actions, right? Um, like for example, relay switch. So you do some electromechanical kind of action. For example, powering on, powering off, right, based on the electrical signals, right? Similarly, solenoid, which controls the flow of water, right? So actuator, in principle, it is going to make some actions. Okay, some of the control signals that are used for making some actions or electrical signals could be used, or air pressure could be used, or water could be used, right? Depending on what kind of control signals that you provide and how the actions happen, the actuators could be of several types. Okay, hydraulic actuators, pneumatic actuators, electric actuators, thermal or magnetic actuator, mechanic actuator, and so on. Hydraulic actuator, from the name itself, you could understand, like giving some hydraulic power, you make some mechanical action. Giving some air, if you perform some mechanical action, it is called pneumatic actuator. If you give some electric power and if you make some actions, then it is called electric actuator. Okay, so actions itself, like if you make some sort of alarms and so on, then based on electric signal, then it would be a part of electric actuators. Thermal or magnetic actuator, based on thermal energies or magnetic energies, we perform some actions. So likewise, so actuators are typically some portion that is used for performing actions. So in an IoT device, in an IoT application, typically you will have sensors, actuators, as well as network devices. When you talk about network devices, I have told you can have edge, um, fog, as well as cloud. Cloud, I think most of you are familiar with that term, right? Or most of you would have used cloud. How many of you have used cloud? Like for example, infrastructure as a service, like EC2 instances, creating EC2 instances or something like that. Okay, so some of you have experimented with cloud, right? What about fog? So let me make one general statement of what cloud is. Cloud basically is, analogously, let us see. Okay, what is a cloud? The real cloud which we see on in the sky, right? What is that? It is scattered here and there, and you can imagine, like, it is very far away from us, and you can see that it is limitless, like, it is unlimited. Clouds are spread across the globe, and it is everywhere you can find clouds, right? So similar to that concept in computers, okay, what people have done, they have created some sort of clusters, okay, data clusters, and they are we can plug in to those clusters, and some providers are available to offer those clusters as and when you need. Okay, like for example, Google or Amazon. Okay, they have uh, tens of thousands of such servers, and whenever you request for some server, whenever you request for n number of servers, okay, or set of clusters, they can offer that to you through internet. So that is important here, right? Through HTTP protocol. So with that protocol, you are able to get the compute as well as whatever is compute or storage or whatever configuration that you need, you can get it from there. So the servers are far away from you. That is one important thing, and the scalability is very high. Okay, how much you need, that much you will get. That is the concept in cloud, and how much you utilize, that much you will have to pay. How much you purchase, right? For example, you say that I need 24 cores. You will get 24 cores, and the right from the time that you get 24 cores, you will start to utilize that, right? So this is called cloud. Whereas fog means, let us analogously think about a fog. Okay, how a fog look like? It is typically placed in very nearer to you, right? And it is spread across maybe in one city, or in a particular region. On particular days you can see some fog, right? And this particular fog is very accessible to you. You can access that, and it is slightly um, uh, spread in a particular region. That's it, right? One particular region. Um, it's not like a normal cloud where you can see several number of clouds as like you see in sky, right? So as similar to that analogous viewing of what cloud is, what fog is. Here also, a fog means it's a set of cluster, or maybe you can call like a small data center located in one smart city, okay, or a small set of cluster which is located very near to the agricultural farm. Okay, why we need that the fog is a small computing unit, a small clustering unit or data center unit, small data center unit, um, which is located near to your sensor networks. Multiple sensor networks are there, and if you are placing this very near to that, many sort of processing could be done there itself. Right? So this is fog architecture, right? Fog from the analogously you have to think. And so what is the difference between fog as well as cloud? If you see, cloud is much more scalable than fog. Computation wise, cloud is much more better than fog. Okay. So fog has limited capabilities and computation power. But it is quite important to do some sort of analytics there itself. Okay. The next comes the edge. Edge, from the name itself, you can understand it's very near to the sensor. Sometimes the sensors could be combined with this edge node itself. Okay, like for example, if you connect to the Raspberry Pi and place the sensor, put together, and do some sort of smaller analytics or filtering of data in the Raspberry Pi unit, then that itself is one edge. Your mobile phone could be called as edge. Okay. Like for example, you have connected a set of sensors around your body, like a smartwatch. You have connected a small ring, which is also a sensor, which is internet-based sensor. And if you are having some other devices like shirts and so on, which is also having sensors. Okay. Uh, if you have a mobile and all the data that from your sensors go to the mobile and it does some sort of processing and makes some visualization and so on, shows the visualization graph and so on in your mobile device, then it is edge-based computing. Okay, so um, like someone is also doing anomaly detection at edge. Okay, some detection, some processing is done in edge. Why people cannot do it in sensors? Because most of the sensors are power scarce, right? So we cannot do that. We should not do that. Then your battery life will be poor, right? So certain computation should be done in edge. The question like, why can't you use the sensors directly to the cloud? We could not do that because certain reasons are there. One is latency. Okay. The second reason is large power consumption at the sensor bed. So these things you could avoid if you are using this cloud. Sorry, edge. Okay. So, having said that, what a basic IoT architecture will look like, now let us move on to the next concept, that is serverless IoT. Okay, serverless IoT. Serverless IoT is really very interesting aspect. Okay. Um, so far, what we have told, I have told that uh, whenever we need something, we can reserve the devices or applications in the cloud itself, right? So your cloud is fully enabled and it is actuated for the entire IoT application. So imagine that you have an agricultural farm and you want to see how many yield will happen or how many productive your agriculture farm will look like. Okay. Um, so imagine that your sensors are not collecting the information every day, or it is collecting the information like temperature, humidity only once in a day. Okay, imagine a situation like that. Okay, so in that case, if you are just using uh, a normal cloud, okay, you will fully reserve the EC2 instances as well as cloud instances continually. Okay, you will have to pay for. We all know cloud means pay as you go. That means whenever you say I am going to use this IoT application, you reserve that. I mean, you start that compute instance, and then the moment when you start the cloud instance, okay, you are starting to use the resource. Okay, you will have to pay both for computing as well as storage, because you will also use storage units, so you will pay for storage, you will also pay for the compute. Okay, those who are aware of EC2 instance as well as the storage units, you will know that, right? So you are paying for both, okay, for realistic applications. But for free tier and normal things, you just use EC2 instance and you are just running that there. But normally you will do it. No, you will pay for both storage as well as EC2 for real applications. Um, the moment when you start to use, it starts to have to pay. So in an IoT application, you can imagine that it is always waiting for the data. Correct? As the example I have told, every day, let us imagine every day, once we are collecting the values, sensor values, and we are doing some sort of calculation. Okay. Uh, so for this purpose, your cloud EC2 instance as well as storage will be enabled continually. Okay. Uh, and you cannot simply stop the application every now and then, right? You start, if you have started the application, you are starting the application, and maybe after 3 months you want to see the status, or maybe after 1 week you want to see the status, or maybe after 3 months you need to see whether the mango became ripe or not. So these are some of the statistics that you want to see in a visual form or something like that, right? So if you are just using cloud as normally what you do, it will not be cost efficient. So these days people are thinking of serverless cloud environment. Okay, serverless cloud is one of the deployment model. Okay, it is a execution model. Sorry, execution model where you are not executing the EC2, or you are not executing the compute instance every now and then. Okay, so uh, you can start the application, but your EC2 instance or the compute instance will not be available. Okay, this means once when some data is informed by the sensor or by some wearable device or some sensor from the agricultural farm, once when the sensor is sending a data to update the data, okay, only at that time the server is powered on. Okay, by doing so, the cost that is involved in for your account for charging is drastically reduced. You want to continually have your IoT application, that is for sure we want to do that. It typically runs in EC2 instance. If it is AWS, we know that. But according to serverless concept, what happens is your EC2 instance will not run. Okay, it will not run only when the data from the sensor reaches the storage unit. The entire software code, along with the state of the program, is taken, bundled, and it is placed in the server. So while placing the data or the command in the uh, server, it will search for the server, which server is available, which server can be used, and now it will start the server. Maybe it will boot and it will start, or it will start from the available, one of the available free server instances, and there it will start the program. And once when the program is complete, again it will bundle back the entire program, and it will place in the storage unit. The cost involved for your utilization, IoT application utilization, will be very, very minimal, just for that CPU computation that it took. Additionally, for storage, you will have to, as usual, you will have to pay. Right? You are reducing the cost involved in the computation part. Right? This concept is called as serverless IoT. Is it audible to you all? Can you please type yes or no? I just want to know whether you are. Yes, very good. Thank you. it once happened in one of the webinar that I was talking for more than half an hour, and at the end, they were saying that, "Oh, sir, you left quite long ago." Okay, so such things should not happen. That's why I was curious to know. Okay, so very good. Um, yeah, Mr. Harish, do you want something to speak?
Hello, sir. Good morning.
Yes. Yeah.
Sir, I'm a PhD student at IIT Bombay.
Okay.
I'm just starting my work related to the IoT.
Okay.
Sir, I just wanted to know the value proposition in the examples that you gave. For example, the tire example that you told. Sir, what will be the real value that is bringing? Analysis, the facility, the comfortability is there. But for that, like we are putting a sensor, monitoring mechanism, the battery system, we are also investing something.
Yeah.
That investment is worth for that
Oh, yeah.
facility that we get.
This is one of the example which people are working on. Okay, I found one of the examples that people have found, experimented. Definitely, it will be useful if you think in another perspective, like how many number of tires should be manufactured, and it is also people are trying to connect this with um, the cost that are already available. I mean, the budget that is already available with you, and the best optimal time for you to purchase. So it is mapped with that aspect, and it is also mapped with the multiple number of developments. I mean, the tire manufacturing that the industries group. So normally, what we do, um, we might have budget at that time. We will not be interested. Okay, we may not, sometimes we are not having budget at that time. The price may go, it may be less. So this kind of optimal finding of at what time you can do things. So typically they are working on that. Okay, so I think this is one aspect of real product development. Research perspective, I think you should think of kind of scheduling, or how you can balance the number of procurement as well as number of raw material required, and how you can reduce the procurement of raw materials. So in that way, you could think of, like there is a concept also, like cloud manufacturing. Are you from mechanical or some other branch?
Sir, I'm from electronics.
Electronics. Okay. So yeah, electronics. I think then you should think about some sensors, right? Some kind of sensors which may be useful in that direction. If you are from mechanical line, maybe this kind of planning or um, say how many procurement could be done, or how much raw material could save. These are all some of the research directions. Okay. But electronics, as an electronic guy, I think you could think of some energy aware scheduling or energy aware routing of such tasks. Yeah, if you are starting,
Sure.
I think there are lot many topics which you can think of. I'm just giving lot of ideas of which you can pick up one or two. Right? Value proposition typically comes based on what kind of work you try to do. In fact, in this case, if you are really saving some raw materials, and if you are helping the manufacturers as well as the consumer, considering the budgeting and so on, that is definitely a good research which people are working on. Okay.
Sure, sir. Thank you, sir.
Yeah. So continuing further with serverless IoT, um, here you can see that some functions are just used, which will enable the enable the servers to work, right? So yeah, it could be done in multiple levels too. Okay, like as you can see, at edge also you can try this. At fog also you could try this. At cloud, particularly, you can try this. Um, it is, infrastructure providers perspective. It will be very, very beneficial. It with respect to the user perspective also, it is very, very useful. As a cloud provider perspective, it is useful because he can properly map how many number of VMs are required, and he can stop the number of VMs in creating more VMs and so on. So he could save some servers too at some point of time. Okay, so in that way, he could save. He could even accommodate more number of customers, because most of the time your IoT application is idle, right? As the example case which I have told in agriculture, that you are just collecting the data only once in a day. So the rest of the time it is not really useful, right? So maybe for 5 minutes EC2 instance is required. That's enough, right? So only for 5 minutes per day you are going to pay. Otherwise, you know, in the traditional approach, you will have to pay for the entire day, and it will continue for the entire time duration when till the IoT application is running. But no, with serverless IoT, we could save that cost. Okay, so yeah, there are several platforms too for serverless functions. One is called kubeless function, iron functions, fission. Okay, FN platform is there, OpenWhisk platform is there. Then Amazon provides Lambda, also Sparta is there. Google offers Google Cloud Functions. Microsoft Azure, Microsoft provides Microsoft Azure Functions. So there are several platforms which provides this serverless function environment. So what we have to do, we have to just utilize those functions, and we want to execute the IoT application. Right? So things are much easier because it is infrastructure providers core concept. Since no, it is having more value both for the providers as well as the customers. This kind of serverless function-based execution model is becoming much popular. Okay, there are certain performance concerns too. You could work on these performance concerns. And there are a number of research directions that you can consider here. Okay, um, like mapping. Okay, can you directly map certain certain devices to the provider, right? For example, um, your smartwatch sometimes will not fit properly to your IoT application, which is hosted in Amazon. Okay, so this is one of the concern. Okay, or you are getting some particular resource, but these resources are not appropriately scheduled. So it is a kind of scheduler problem. Okay, can we offer some energy aware scheduling, right? So in an IoT application, we all know a lot of sensors will be there, a lot of actuators will be there. Or these, we also know that the sensors are battery powered ones. So when you run your IoT application, whether your IoT application is always pinging the sensors. Okay, so considering your IoT application, the entire IoT application, um, can you, provide some efficient approaches there? So this is also one of the research aspect. Okay, serverless functions are having a lot of importance there. Um, Security is another aspect which I really didn't touch, but n number of works could be done in that perspective too. Like, typically, what will happen if the device is hacked by some software? What kind of authentication you need to provide? What kind of encryption technology you should provide? Like people are talking about lightweight cryptography and so on, right? Um, Whether you have to deal with the tampering of data, can you apply blockchains for that? So likewise, some of the performance issues related to security concerns are also there. uh, Memory size problems. Very importantly, which we want to note here is serverless functions. As the name indicates, it's just a function, okay, which is going to trigger the real execution of your program. So this particular function is very, very short. Okay, therefore the providers, let it be Google Cloud Function from Google or Amazon's Lambda, these functions are limited with particular size. Okay, so therefore it is provider specific. So can you offer some caches for accommodating frequent such functions? Um, can you provide some other alternative to accommodate more memory units? Okay, and if you see the cost, if you see the cost model, currently the serverless functions are based on the memory size. Okay, but memory size is also interrelated to the compute units. So how much cost could be reduced if you increase the cost of the CPU and reduce the cost of the memory? So these are all some of the research aspects which you can think of in this direction. Okay. Why serverless is very important for IoT? Because typically, if you take any of the IoT applications, most of the IoT applications, the application will survive for long, okay, very long period, maybe for years put together. But the sensed values will be periodic. Most of the time, it will be periodic, but the time between each sensing values will be uh, very, very large. So as I have told, let it be like even vehicle monitoring. Okay, in a street, maybe tracking a particular vehicle. Okay, so whether that vehicle reached a particular street or not. So if that vehicle is traveling only once in a week, or maybe weekends only, so in the whole week, maybe only twice it will cross that street. Okay, for that you will keep on tracking that particular vehicle to get the information. So sensor may be sensing, and the data that it wants to compute may be very, very limited. Okay, and that is not also so frequent. So in that cases, the serverless functions are very, very useful. And so in those serverless based functions, you can see such kind of issues. Also, non-availability and language-related issues are also there. Say, like for example, um, Amazon Lambda supports a certain programming languages only. Okay, Node.js, Python, and these kind of languages, not C++ or something like that. So, uh, uh, so these are all some sort of issues. So if you have written an IoT application, you know, and if you want to target it using C++ model, then there should be a kind of wrapper. So when you write a wrapper for that, definitely the performance will be low, right? So all these are research aspects which you can think of. Okay. Similarly, non-availability issues. Um, Sometimes, the serverless functions have already, reached a point where it needs some compute. It is searching for the compute unit, but at that time, if it is not able to find, non-availability will become an issue. Okay. So there is also a concept like cold start as well as warm start problems. Okay. Um, Typically, a cold start and warm start are given to the creation of instances when a serverless trigger happens. Okay. Um, when an event is triggered and now it is searching for the server, if the server is readily available, it is powered on and it is readily available, it is still idle, then we can call it like warm start. We are providing a VM or a instance which is readily available, right? Therefore, it could be called as warm start. Okay, the performance that we get with warm start will be definitely different from cold start. What is cold start means? It is searching for the compute resource, but it could not find it. Okay, then it has to start from the scratch. Like it has to boot the machine, okay, with boot system, boot configuration informations and so on, and sometimes boot failures could happen. Uh, Due to that, some latency will be there, and so on. So these are some of the performance related issues. Okay, like mapping, non-availability, cold warm start, impact of memory sizes, security, and standards. So to evaluate this, or to understand what kind of problems are there, there are certain monitoring procedures. Okay, those who are interested to do some research in monitoring mechanisms, you could also do in this way. Like there are certain approaches like tracing approaches there, sandboxing approaches there, modeling or prediction approaches there, as well as language inherent approach or instrumentation approaches there. Okay. Tracing approach, what happens is um, you go through the messages of serverless functions and you will try to understand where the problem occurred and how the problem occurred. Of course, some tools are required. Okay, as a program or application developer, we will not be interested to develop such kind of tools. Uh, but there are certain communities where people develop performance analysis tools for that. Okay, so we can use those tools and we can check the performance issues of performance issues. Got it? So tracing means you go through the log or error messages and you figure out what is the problem. Sandboxing approach is where you create an isolated environment, and in that isolated environment you will create a particular instance and you will see what problem could happen in a situation. Okay, so you raise some situations and you see what kind of problems are expected or possible. Okay, then modeling as well as prediction approaches are there, where you collect some metrics, you see what is there, and then based on that metrics you try to make some analogy out of that. Okay. The last one is language inherent. That means, for each serverless function, you create another function inside and you try to monitor, you try to see what will be the impact, what will be the effect of, you know, like for example, execution time of the serverless function. Okay, so that is language inherent or instrumentation approach. So if you have written a serverless function using Node.js, then you insert two functions just at the start as well as end, and you calculate the execution time. Right. So these are some of the four different performance mechanisms, monitoring mechanisms, and based on that, there are certain tools. Okay, of course, it is again proprietary ones. Okay, most of them are proprietary ones, except you can see like Prometheus is there, which is open source and it is used for tools Prometheus is quite open, therefore you can use it along with AWS, or you can use it with something else like Google also. But specific to Amazon, you have Amazon X-Ray. Amazon also has CloudWatch. Okay, Google, it has Stackdriver, application insights from Windows. Okay, I mean Microsoft. Okay, Tundra is separate from a company. VMware offers Wavefront. Epsecond is a separate company which offers it. So likewise, there are certain tools. You can use those tools and you can search, check what kind of performance issues are there. Okay. These tools, I have just made some classification, um, like whether it is commercially available, whether it is open source, whether free trial versions are available, whether it is like uh, analyzing based on logs or plugins or traces, whether it is available as a library or agent or service, whether it could measure a function or a task or application. So depending on these classifications, you could easily understand which tool you could use and you could write for your IoT application. Got it? So these are some of the different research works. Additionally, here I have shown some of the research directions where people are still working on. The serverless functions, since they are short-lived, uh, what kind of approach you could provide so that you enhance the uh, lifetime. Similarly, the volumes. Okay, uh, can you use large volumes of performance data, especially for visualization purposes? Okay, especially when you take some IoT-based applications, industry-oriented applications, like visualization becomes a major thing. Like you want to see something, virtual reality may be required. Okay, so can serverless functions work on that aspect? Okay, because memory size is less. Okay, can you use PA tools overriding vendor lock-in problems? Okay, in cloud we normally know that vendor lock-in becomes a major hurdle, right? If you see, uh, so far whatever I have shown, also you can notice that most of them are proprietary ones. Like Google, they have their own setup. Amazon, they have their own setup, right? So easily you will end up with vendor lock-in. Your application could be locked in between in the system itself. I mean the providers this. So how can you override? Can you offer some federated environments? Okay. So federated kind of architecture or federated frameworks. It is also one kind of research perspective which people are working on. Okay, integrating all these multi IoT systems or multi-layering of IoT systems. How can you integrate them properly? So that is also one of the important research aspect. Of course, energy consumption is very, very important metric in most of the IoT-based applications. Uh, like if you take Arduino and all, there are certain libraries already available, like narcoleptic library, which you can simply use and you can see how many energy consumption was consumed in systems, right? So these are some of the works which you can really do. So what I have so far explained is um, how what is basically IoT. I have started from there. Then I have told the trends of IoT. Different subdomains of IoT was discussed, right? Five different subdomains of IoT were discussed, and there's several topics where you can work on, which discussed. Then I talked about the IoT architecture, generic IoT architecture, as well as the recent very popular research topic related to IoT, which is serverless IoT architecture that was also discussed. So by this, I have covered the first part of the lecture, right? So if any kind of questions are there, you could ask, and if not, I will. We shall have like 2-3 minutes break, and then we will start the next part. Any questions? So let's. I mean, I will take 2 minutes break. Okay, and of course you can also have 2-3 minutes break, and we shall join for the next part, that is writing. Okay, because this we need both parts for research, so we will continue with the next part after 2-3 minutes. Is it okay? Okay. So 1 minute. Thank you. I will come back in 2-3 minutes. Okay. Welcome back. We are moving to the second part of uh, the talk. Okay. Um, I believe that we have the 1 hour to discuss about the writing aspects. Well, so most of us are in the initial stage, or maybe a few are in the ending stage of research. Right? Yeah. Yes, Harish. Anything
Sir,
to
will you share
discuss?
the slides?
Sure, I can share the
And
slides.
can
Yes.
we get your appointment after this discussion?
Yeah. I mean, uh, at particular time through email we could discuss, right? Like at any time. But sometimes I would have class, and sometimes there are some other meetings too.
I'll write a mail and
Other than
request, sir.
yeah, sure.
Sure, sir. Thank you, sir.
Thank you. Great. So we are all now ready to make the next part, that is writing. Okay, writing is basically an art. Okay, it is of course PhD. From the name, we should understand that it is Doctor of Philosophy. Doctor of Philosophy. It's talks about philosophy, right? Philosophy means human behavior, basically, right? It's studying the principles of behavior. So by the end of our PhD, we have to really be much ethical. That's the meaning. Okay, and we also have to be cautious in writing. Okay? Uh, we should not, at any cost, we should not copy, basically, uh, from some of the some things. Okay? We could read, we could understand something, and we could write something, uh, as like how you write in exams. Okay. Normally, when we write exams, at the MTech level or at BTech level, we write exams. How do we write? We read two textbooks or three textbooks. But at the research level, we are not just going with the two, three textbooks, but we are going to read multiple papers, like at least 500, 600 papers, very importantly. So I will just show you, I will walk you through this journey of how to write an article. Uh, Few of you may be having some experience in writing. I'm just going from the base level so that everyone are comfortable with that. Okay. Uh, Typically, the articles are of few types, at least to some extent. What I have come across are like research paper, review articles, magazine articles, then short papers, as well as case studies. Research paper is like the paper where you find something, okay, um, out of some experiments or something. You find something, and based on that, you are showing what you have found to the community. Okay. Um, the very stepping stone, as I have told earlier, PhD is Doctor of Philosophy. So something you are going to do for the society. Okay, out of the behavioral change that you have made, which you have created by yourself. Okay, so it's a long journey of reading and studying, and after that only we are getting this PhD. And so philosophically, we are motivated, and we are doing some findings. That findings we are showing to multi connected people, or to your community, or to your fellow mates, and so on. So a research paper is basically something that you already found, and that finding you are just showing to others in the form of writing. Okay. Review articles is not like research paper, right? Because you are not doing any kind of experiment or something, or you are not evaluating something, but you are you are you have done so many such research works, okay, and you have also constantly reading many articles, okay, and out of that you start to write a review, like what are the best things, or what are the challenges in a particular domain, what happens in a particular IoT field, and so on, like that. That is typically called review articles. Magazine articles are mostly invited ones. Okay, an editor of the magazine uh, will normally identify certain authors, and or most preferably from industries. Okay, and the editor will ask that particular author to write something, some new things, what is there, and comprehend and so magazines are typically like that. Okay, some new findings even need not have experiments. Okay, if you see some of the IEEE magazines, you will be astonished to see, oh, what is this? Nothing is there. They have just drawn some architecture, and they have simply explained something. Even the way of writing is not comfortable as like what you can see. It's I will be explaining to you. So magazines are typically different. It is mostly invited ones, and these invited ones are typically from industries or some universities too. I am not saying that the academicians didn't write magazine articles. Magazines, most preferably from IEEEs, if you see, they are from industries. Short papers are very very short length, typically like beginners, PhD beginners, or someone from someone who just started their research, uh, who already have some very minimal result, or like a starting point result out of a big architecture. Let us say, let us take an example, like in an agricultural IoT agriculture field, you are attempting to develop a serverless kind of environment, but you are saying that you tested it with one particular sensor and it is working. Okay, so you wanted to show this to the community, maybe to conferences, or even to journals, but very very short. You are just showing the architecture. You are getting the evaluation from multiple reviewers. Okay, so this is typically short papers. Okay, case studies are very specifically meant for one particular case, or maybe 2-3 cases. Okay, considering one particular agricultural farm, how did you do the experiment, what happened, and so on, so on, so on. You will be explaining this, and so these are typically different types of research paper, research articles which you can see in journals. Okay, but conferences are as you all know, there are several conferences like IEEE, Springer, LCBR based, and so on, so on, Scopus indexed, and so on. Preferably, it is better to use Scopus indexed conferences. Um, how to find the Scopus index conferences? You just want to type similar conference name in the Scopus site. Okay, Scopus database will then have to show your the conference title. If it is there, then it could be probably uh, told that it is no Scopus index, because the safest side, if you prefer to go for conferences, is to choose some previously organized and successfully published conferences. So it is better to avoid new conference, like first international conference. Okay, this kind of conferences may be susceptible, like you might not know whether they are really going to publish it in IEEE or Springer or so on, even though it will be listed in the IEEE site as well as Springer sites. Okay, because the coordinator might not have sufficient knowledge to do the post-conference editing and so on. So there is a high probability that it will not succeed at the end. So it is always advisable to choose the at least third conference or fourth conference and so on. And of course, you should cross-check whether the previous conference proceedings are already published in the appropriate indexes. Okay. So choosing conference or choosing article. Okay. Whether it depends on your results, right? So if you have done some experiments, if you have some results already, and if you want to target, if you are a early stage PhD scholars, you could target the, the short paper versions, okay, or PhD symposium kind of versions, but in the good conferences. Okay. This is one thing which we want to note. Then writing, okay, because our motive is to see how to write an article, right? So first and foremost is we should have vision, interest, result, and contents ready for the paper. Okay. So if we don't have the vision, like I'm going to write an article on say finding the healthcare IoT for elderly people. So I want to say something about this to the community. So you should have both the audience as well as who is going to write, and that vision should be very clear to you. Okay. So first and foremost is we should have that vision. Who will be our audience? Okay. Whether they are really interested to listen to this particular topic. Okay, that vision should be clear. What topic you may need to write that vision. Okay, what you are planning to write, that kind of vision should be clear to you. Okay, the interest should be there. See, for example, I am working in serverless, but my interest is not in serverless. Then there is no meaning of investing time there. Okay, I'm an interdisciplinary guy. I wanted to do everything that is possible. That is my interest. Okay, if that interest is not there, you cannot do it. Got it? So interest of learning something in a particular field is very, very important. Only then you can proceed further with the writing process. And then we want to collect the content. So there are certain steps here. I think I will discuss one after the other. So this particular step only will take longer time. Okay, when you typically do a research, it is also a mapping between the particular person as well as the supervisor. So if the supervisor is working in some other domain, and if you are working in some other domain, or if your interest is in some other domain, there is a clash. Okay, you cannot really do the better results. Okay, so the mapping should be very clear, and the interest to write should be clear. Content should become ready for writing. Okay, and this particular step is very, very lengthy step. Then selecting an appropriate journal. Okay, we want to select a journal, or whether we need to go to a conference that you have to select, and then only you are starting to write and revise. Okay, this is typically a iterative process. I believe that some of you have already written some papers. Okay, but no, we would have changed some orders here and there. It's fine, no problem. But although there are no very strict procedures like this is how you want to do, because some people start writing from abstract and they start from title, abstract, and keep on writing. Some people have a practice of writing the bodies first, and then write the introduction and the title at the last. So it varies actually. Okay, so but whatever you follow, okay, um, the the steps that I have shown here is well accepted. Actually, many people are following in this fashion. So that's why it is also. I'm just showing my perspective, which are already carried out by many people. Okay. The third step is write and revise. Fourth step is get an advice from an expert, okay, which normally people will not do, right? See, of course, those who are above PhD, they normally avoid this, okay? But it is always a good practice to get an advice from an expert, okay? Say, for example, if you are a PhD pursuing candidate, you normally get an advice from your supervisor, that is fine, okay? You are getting an advice from the supervisor, that is fine. But if a supervisor is writing an article, they will have to get an advice from an expert, typically from the some editorial board, some members, or some of the close friends who are working in the particular field. Okay, getting an advice sometimes can be risky. Okay, because sometimes they could place your work too. But nevertheless, you should find the appropriate team who will be very loyal as well as who will be very close to you. Okay, that is very important the step. So why we need an expert advice is because you always, even though you are a postdoc or you are a professor or you are someone who's very senior professor, well versed in a particular domain, if you are writing an article, okay, uh, you have a particular viewpoint and you are keeping on expressing it in that way. But later on you will understand that once when the expert reads and once when he or she gives the command, you will understand that that could be incorporated. Okay, the extension would have been done in that direction. So that expert opinion is also one of the important aspect, which is step 4. Step 5 is submit for a review. Okay, then carry out the review comments and publish. Let us take one after the other. How do you normally download articles? I believe that few of you have already done, right? So, given a target, like you want to write an article within 2 weeks or 4 weeks, okay? Let me typically ask you, how much time, how many of you are, how many of you already have published papers? Can you type yes? How many of you have already published some articles? Maybe in conference or journals. Few of you would have published anything, correct? Yeah, conference 3. Okay. Yeah, very good. Very few are there, right? Okay. So, first of all, then, as a entry-level PhD candidates, it may be important to notice some of these sites. Okay, where to download the article, because the first, first step is to collect as many content. Okay, first we need vision, right? Like what you want to say to the community. So you are talking to a few people, you are understanding something, and after that you are you are coming with some vision, or you are identifying a topic, right? So in a PhD, normally you already have some vision and you are starting a topic. See, most of the PhD scholars will end up with 6 years, 7 years, 8 years. Why? Because they are not really focusing on a particular vision. Okay, um, a PhD can end up within 3-4 years or 3.5 years if you are really focused on a particular topic. Okay, um, as there were some comments also um, by the sorry, there was one comment saying uh, now it will be very difficult, tomorrow it will be still further difficult, and only later it will be beautiful, right? So most of them will end up by the second day itself. Um, this means, right? This means we start doing a research, we continue going on that direction, and we will not, if we are not focused on that itself, we might end up with struggles. Okay, sometimes the supervisor will dictate that you have to do it in this particular direction, you do it in this angle, and you keep on searching, and finally if no papers are there, you will get annoyed at some point of time, and then you stop there itself, right? But uh, only after only after you get the first paper, only after you get the first paper in maybe the journal, you will understand, oh, that's it, okay, this is how we want to do, right? So initially it will be very very difficult to collect, gather, and validate things. So the first step is very clear vision, okay, fixing the topic. If you don't fix the topic right from the first year of the PhD, it is going to be very, very tough to continue the research uh, and never change the topic, never change the idea or the vision of what you want to do, and keep on digging further into the topic. That is why it is called research, okay, repeated search. A repeated search. If you do that, you can easily complete within 3 years or 3.5 years. If you are not focusing on that particular topic, if your vision is not there, if you are not focused on that, it will keep on moving here and there, and you cannot complete the PhD on time. Okay. The vision should be there, and based on that vision, based on the interest. Okay, again, interest is also very, very important. If you are really interested to do PhD, okay. Normally, some people say that I want to do PhD. I need the 3-4 papers. I need the 2 essay papers. I need 3 essay papers. That's it, just for completing my PhD. Then that is not really a PhD, honestly speaking. Okay, so it should be a passion. Okay, PhD, at the end of completing or getting a PhD degree, you are just uh, a level where you say that okay, you have just started the research. Okay, after that, truly the real research component will start. Okay, so if you want to really complete the PhD, uh, you need passion. Very, very important. Okay, interest and passion. If you don't have that passion, you will simply think of, okay, I need 2 journals, I need 3 journals, I will complete that and I will finish. That is not really a PhD research. It is something, as I have told earlier, doctor of philosophy. It is a behavioral change which contributes to the society, which provides something to the society, right? So that aspect should be there. So for that we need a vision, clear vision. Okay, for example, if it is interdisciplinary, I am targeting an interdisciplinary work. Okay, and I will address these problems, or I will target some sort of societal problems. That is my vision. Okay, and that is my interest, and my passion follows in that. So when that passion is there, you are automatically directed to that, path. So you will start to do things, lot of things. Okay, so there are certain ways how we can identify and download the content, which is the first step for writing the article. So one is you like scholargoogle.com. How many pages we want to search in scholar.google.com for a particular topic. Um, Typically, the best practice is at least to go 50 to 100 pages. 100 pages. Okay. Um, these are all some of the hints which you can make a note. Then similar to that, we should not just stop to only one site. Okay, for preparing a content. You can search academia.com. You can connect to through your LinkedIn. You can start asking some papers. You can search from Google. This ResearchGate, lens.com, patents.google.com also gives you the recent one. Google Trends you can search. ARXIV prints you can search. Google Books you can search, as well as academic Microsoft Academic. So these are some of the best, I would say, sites where you can start searching the article. So first we have the vision. I want to do something in this particular field. I have the interest. I am going to really do something. Okay, I'm going to spend like another 3-4 years really, and solidly I'm going to do something, and then I'm going to continue this throughout. So that is what the passion means. Okay, so with that intention, you are going to start. So a particular topic is started, and for that you are now collecting the data. So see here one of the model which people have shown, like with the query keyword like telemedicine or e-health or telecare or telehealth or tele remote monitoring or m-health or like that, some or constraints were given, and Internet of Things. This was provided in the Google Scholar, and also in the other search sites. Records relevant to Web of Science articles they have noted, IEEE they have noted, and Science Direct they have noted, and totally around 2,121 articles were selected. As a entry-level PhD candidate, it is really important that you should at least download these many number of articles. Okay. To write one article, they have downloaded 2,000 articles. Okay. Just I am showing you the step by step what you can do. Then some duplicates were there, they have removed. Okay. Then out of that, records screened. Um, Records excluded after reviewing titles and abstracts. So what they have done, they have went through the title as well as the abstract. Okay, only the title and abstract, and from there they are matching this with the vision as well as the interest of the particular candidate. Okay, PhD is candidate wise, it is Doctor of Philosophy, right? So for a particular candidate, that is what. So supervisor is not going to do anything there. Supervisor is just seeing whether it is matching with his interest. That's all. Supervisor can never do anything. Okay, as far as a PhD is concerned, supervisor can just say, okay, you are going in this direction. Okay, you are fine. Okay, you have to start now. You have to stop now. Something like that. That's all. I think a supervisor should really do. A PhD candidate, he is like figuring out from his interest, from his vision, he is figuring out whether the title as well as abstract is matching to his interest as well as to his vision. Okay, and then he has to do some full text studies. See, around 774 articles were read, full text were read. Okay, and then out of that, after reading the full text, 633 articles were removed. Okay, it was not fitting to him and for that particular period. Okay, maybe, and after that, 141 papers were used for qualitative analysis. Okay, so this is a long process, very important process. Okay, the longer you take for reading and following this step, the more you can do results. Note this point very importantly. Okay. Research is, with a particular focus. You are focusing on one particular thing, and you are you are trying to you are trying to do this PhD. And now, starting from this mission as well as the interest, you have now comprehended everything, and you start reading. Very extensive reading is very, very important for PhD candidates. Okay. Every day morning, it is better to read and write some synopsis of whatever you have read. Before going to bed, it is also good to read some articles, at least 3-4 articles. So you will get some ideas in the morning, and again you are refining that, and you are making some notes what you could do and so on. Everything is focused on a particular topic. Okay, that is very, very important. If you start with a particular vision, you should. If you start with a particular topic, you should do that iteratively in the same topic for at least for 4-5 years to get the better result. Okay, at least if you are doing this step, okay, this step for 1.5 years, you are doing the best. If you are doing it for 3 months, you are doing little best. Okay, if you are doing only 1 month, it is not really beneficial. Okay, it will not generate the long-term objective of what you want. It is this is from the source, from the site. Okay, after you clearly refine the particular set of articles, it is it is important that you want to read, right? So it is always told that 3-pass approach of reading article is important. Okay, it is not that only once I will read and I am done with that paper. You cannot do research. Okay, at least 3 times. At least 3 times. Okay, the more you read the same paper, you are going to get the more understanding at the late. Okay. Maybe you are listening to the talk now. Maybe after 3 years, if you are listening the same talk, you will find some other meaning out of this. Okay. If you are listening to the same talk after 4 or 5 years, you will get some other meaning at that at this particular talk. Okay. So reading is something like that. Today, when you read, you cannot understand most of the parts. Okay. The day after tomorrow, if you read, you are getting some more clarity. Okay. So first pass, second pass, third pass is typically kept for that purpose. Okay. First pass is just bird's eye view. You should not read all the content in the first pass itself. It's always recommended for PhD candidates. Some people, what they will do, they will just download 4 or 5 articles, okay, and then they will start to read, understand, and so on, and they will get confused. Oh, what is this? It is, at the end of studying everything, they will understand. Oh, this is not useful. And they will sometimes get pissed off in the middle of the PhD itself. Okay. So, as I have told, you collect as many articles as possible from the sites that I have shown. Then you are doing this 3-pass approach to filter and bring the level of papers to this, at least to the minimal number, like n is equal to 150 or 160 number. Okay. The second pass, it is a little detailed, like you will also read the proposed work. What did they propose? Okay. Did they really do something? Whether figures and tables are correct? Okay. These things should be discussed or understood at the second pass of reading the same article. Very important. Okay. That's why I'm saying vision should be fixed. The topic of your research should be fixed. Okay. Some additional words can be added later, but no, you should not change this topic. Okay. And the survey papers are fixed now. And now you are going just, first pass, second pass, third pass. And in the third pass, what you are doing, you are trying to understand the paper very clearly and you are trying to virtually implement that. Okay, uh, the best way of reading article, some people normally try to read extensively. They read for 2-3 days and they will forget everything. Okay, uh, they will not remember anything. That is not a good practice actually. Okay, so you read uh, constantly. Okay, constantly keep a separate note, separate book. That file. These are maybe sometimes people think that why this is really important, but these are all very very important things. At the end, you have to recollect what all things you have done, how productive are you doing the research, right? So the third pass is virtually virtually implementing things. You attempt to see like no, I am implementing it. Okay, that is third pass. And then having sufficient result. Okay, so with that, after reading you are getting some ideas and so on. Imagine that you are going to write one survey article or something like that. Initially, survey article, of course it is good to do some experiments and so on and see, or based on your MTech practicals and so on, you virtually you could visualize and see how that's implementation could be done. Like for example, they would have told that they have implemented with Python, and these are the packages that they have used and so on. So virtually you can visualize and see how that how they would have implemented. If you are getting a grip on that, then that will become one of the count out of that 141. Okay, so that becomes as one of the count of the real paper that you want to really refer and read. Okay, so that kind of papers, okay, you take, and whenever time permits, you keep implementing and seeing, checking whether you are able to experiment or implement that work. Okay. So, assuming that you have done such similar virtual implementations or some real implementations for a certain number of papers, at least it will take a few months. Okay, and after that, what you do, you have to select an appropriate journal. This is the second step. Okay, some people what they will do, they will no supervisor will say you write an article, then immediately they will jump and they will start writing an article, and then they will search for the journal as well as conference. But the best approach is to select an appropriate journal before you write. Okay, why that is important? Because see, you are choosing an article, choosing a journal, say some IEEE, some journal, or LCV, some particular journal. You will start to read relevant articles from that journal itself. Okay, so that is therefore that is very very important. See, um, how to select a journal? That is always a confusion. Okay, many of us also get that confusions. Some people submit to a journal, and then once when they are rejected, they get get pissed off. They are they stop going further, right? For another 3-4 months. Okay, by that time the topic is outdated. Okay, the topic will never get outdated if you are repeatedly searching in the same topic. That people people will not recollect. Okay, of course some new findings, new coming, new additions, you can keep on adding the later stage. But no, if the vision is not clear, if the abstract, the topic of research is not clear, and then you will end up with something new things. Okay, so that you have to avoid. And how to select a journal? Okay, um, so that is the next step, right? So selecting a journal typically is based on impact factor. Normally, people there is a site, to search the impact factor journals, right? So you can, it is always important that you search such impact factor journals, and you want to identify those impact factor journals, or you can search some journals that are cited in some patents for some patents. So those journals also you can choose, and you can start to focus on that journals, so that you get some idea. Otherwise, what you can do, easiest approach is, you see you are working in a particular domain, and you know some of the authors, and some of the leading authors, or some of the authors are familiar to you. So you can choose one of those journals for your work. Okay, selecting a journal, or there are some tools. Okay, all journal publishers, they are nowadays coming up with appropriate tools to suggest you which journal will fit to your topic. Okay, so having some particular content, now you are selecting a journal. Okay, you are coining some um, terms. Okay, title, and based on that title, if you provide it to some of these tools, it will suggest the best possible journals. Okay, you can choose the at least 2-3 journals in your mind. Okay, and you can focus on those 2-3 journals when you start to write your article. Okay, so that is the next part. So please keep a memory on one of those. Okay, and then what you will do, you have to see how your topic is relevant to some of the similar papers that are already published. Okay. Uh, Also, you should see whether aim and scope is fitting properly. Okay. Although Journal Finder has given you the appropriate journal, still you want to check this. Okay. Also, obtain opinions from the previously published authors if possible. Okay. And then you have to check the publication time. See, sometimes you may need to publish it within 3 months. You may need to publish it sometimes within 2 months. So that kind of information may be available on the internet, on the particular journal's site itself. Okay. And note that there are several special issues. Most of the special issues are invited ones. Invited ones in the sense, like the editor will specifically choose some of the authors, and he will ask those authors to submit the article. Okay, so in that case, it is not appropriate to send your journal article to special issues. Okay, so therefore, selecting a journal is very, very important. You can get the advice from the supervisors too. In most cases, if the discipline is changed, okay, say for example, you are working in a particular research domain. For example, now you are proving that your work in the past was something related to bioinformatics, and now you are moving to IoT. Okay, then it typically takes some time to get your paper published. Okay. Why? Because the journal editors as well as reviewers are not confident whether you are having sufficient knowledge skill in that new domain of research. That's the reason I'm always saying in your PhD, it is important that you fix the particular topic or vision, and based on that you have to follow. Okay. The third step is write and revise. Okay, so this is this step particularly might take time for some people. Some people it is fast. Okay. Step one should be definitely fast, definitely slow. Okay, so that you will get much clarity and you are really doing a very good research. But step three should not be fast, should not be slow. Okay. It need not be slow. If it is slow, it could be the reason, like procrastination. You attempted to complete within 2 weeks, but you are only completing it later, very late. So that could be avoided actually. Okay. Particularly, some sort of time management or something maybe required. Okay. So let us see the structure of the paper. The core part of the writing article. Let it be your conference or let it be journal or whatever. Uh, it depends. Like journals, a research paper typically will have 12 pages to 15 pages, right? If it is conferences, we need only 6 pages. So a conference could be something like a fully completed work. Okay, fully completed work, but it may be one portion of your work. Okay, um, so if you complete 2 or 3 such fully completed works, then it is appropriate for it. Okay. So some most of the journals normally expect uh, something newly completed or newly new concepts as well as new things. Okay, novelty. They normally say novelty. Okay. Novelty is very very important. You cannot simply write some content in some conference and you cannot do that in a journal, provided if the journal accepts. In the journal scope site, you can easily see that they would write like extended conferences, extended conference articles, or available or extended conference articles could be published like that. They will write a sentence. Okay. Only then you have to submit the extended version of conference articles to the journal. So, okay, having identified the journal, having the content ready, now we are going to write the article. Okay, how to write an article? Okay, there is a proper structure, clear structure. Don't modify the structure of the paper because for long years, okay, very long years, researchers are used to this structure. Okay, why? Because they want to quickly jump. As I have told, how to read an article. They are used to the 3-pass method of reading article. Okay, so if you are changing the structure, then they also will get confused. Okay, readers will get confused. So you cannot change the structure of the paper. Okay, so this is how a structure of a paper will look like: title, abstract, keywords, introduction, related work, uh, method or proposed work, and in some cases, you can extend that method even further detailing, and then experimental results, conclusion, as well as finally references. Okay, structure you should not change. Title should be very concise. Okay, it should be very very short, not very short. Okay, not very short in the sense you should not write only 3-word, 4-word title. Okay, a title should contain at least 7 to 8 words, and it should not exceed say 20-25 words, or even 18 words itself is a big one. Okay. Title should contain almost what you have already done. Okay. Title should contain that. Abstract is going to give the important aspect of your paper. If your title is not good, they are not going to, they are not going to read. Not only that, if the title is not correct, they are not even going to download your article. Okay, if the title is not good, they are not going to download your article. So they want to download your article first of all. Okay, so you have to write a good title. Second, your abstract should be very, very good. Why? Because it has to go to the second pass reading. Okay, so therefore abstract is important. So what should be there in abstract? It has to have at least 4 parts. 4 parts are required. One is what? Okay, what is all about that particular topic? Why that is required? Okay, how you have carried out, or you have solved that particular problem or whatever, and because of your solution, what kind of impacts are reached or attained. Okay, so these 4 parts are very, very important in abstract. These 4 parts are not there, again you are missing something in abstract. So usual reader will quickly see whether impacts. They sometimes some people might want to see what happened. Okay, some people in the particular field will not be interested to read what and why and all. Okay, they just jump to how. Okay, how and impact. So therefore, this model is also very, very important. If you are trying to change this, like if you are writing first the impact, and if you are just saying what happened, abstract is not full. Okay, it is not crossing the second pass. Got it? So you should think of the reader and you have to write. So that's why this procedure is important. If this is not there, it is not creating much value to the reader. Okay. As you can see, title and abstract is mostly available in for all readers. Okay, if it is published. So therefore, your abstract should be very clearly and carefully written with sufficient keywords too, so that you are trying to combine many people or many audience to the article, or appropriate audience to the article. For example, if you are writing some article relevant to bioinformatics, and you are including just IoT in the keyword as well as in the abstracts, all IoT people will try to read your article, and then they will end up with wrong comments. So first audience is your reviewers, right, or your journal editor. So he will immediately remove, or he will immediately reject without any word. Okay, so that should not happen. So that's why abstract as well as title should be very clearly written. Then comes the introduction. Okay, typically what you should have for for 1 to 1.5 pages, you normally should have the general context of where you are addressing existing works in a very short form. Okay, what kind of challenges they have faced, that should be written next. Okay, then what kind of methods you have followed, that should come next, and what experiments you have carried out, that should come next, and what kind of key contributions, that should come next, and then the rest of the article talks like this. Like for example, section 2 explains the related work, section 3 explains the proposed work, like that you should mention. This structure is also very important. If you are changing this structure, again it is going to confuse the traditional readers. Okay. Blindly you should follow certain structure. If you are following this structure, then the possibility of acceptance in journals as well as conferences are very high. Got it? So please keep this in your mind. Then about related work. Here, no, you have to talk about the extensive research that you have already performed. So you have to cite every no, works that you already have referred and you have concluded to say 150 articles, right? So these 150 articles, if it is conference, you may need only 20, 25 articles, right? So you may have to stick to that. Similarly, if you think that it's a journal, if it is a survey kind of article, you may need to show at least 130, 100 articles in the reference. So that many related words you may have to highlight. Okay. So see, if it is typically a taxonomy kind of thing, people will really like that. Okay. Or if you want to show the pitfalls of other works, that is also important here. You should typically drive the audience to your research work. That is one important aspect here in related work section. Then proposed work. You are some new model you have designed or something new you have defined, so that you can illustrate here. Of course, very importantly, this you should explain with the diagrams. An article without diagram is definitely a rejected article, I would say. Okay. So in a proposed method, you should have appropriate diagrams to explain clearly each and every components, and it should be with utmost clarity. So you can use present tense, simple present tense there, and you should explain very clearly. Don't use very confusing words too. Okay. Some people think that I am writing an article, so you should have so many vocabularies and so on. You should use the appropriate vocabulary, but don't use some confusing words, some very hard words. You can represent this meaning in 2-3 words. So you should not use something which is not very common. Don't use that, especially in technical writing. If you are for some literature article or something, that is different. Okay, in technical writing, you should never use some hard words or very tough words. Okay, very common, but no, you should not confuse with very simple words also. Okay, so if some appropriate good words are there, you should try to use those words. Okay, so it should be very simple, as well as it should give clarity. Very important. It should give clarity. If possible, some mathematical notation should be included here to explain your problem definition. So very clearly, we want to show what kind of problem you are solving and how you are solving it. Okay. If you want to make the algorithm even better, you can draw some flowchart diagrams or something like that, and you can explain that. The next section is experimental result section. So here you can very importantly, first part is setup. This also people miss most of the time. They imagine they think that I have done the experiment. No one should know how it is done. Which normally people commit at the first stage of publishing articles. Okay, but that is not the right way to get the paper published. It will not get published. Okay, the reviewers expect something to virtually experiment that. Okay. So if they are not getting proper what to say, that experimental setup how you have done, they are not having the clear cut information to judge whether you have really done the work or not. So very explicitly you should say how you have done the experiment. Okay. That step should be the first one, and then you should demonstrate the findings. Okay. Say for example, you have made lot of assumptions, means you should definitely show that, specify that assumptions, so that the reviewer can understand, like, okay, these assumptions are made. Um, Out of these assumptions, you can get these results. So that virtual implementation is clear to you. Clarity is there. Okay. If that is not there, I'm sure that the paper will not get accepted. Okay. So that is very important. Then showcase that your findings are impressive ones. Of course, using the graphs as well as some modern graphs and tables. Okay. Here you should not be very simple. Okay. Wording should be simple, clarity should be simple, but figures and tables should show some new way of representations, which normally the reviewers will like. Also, if any limitations that you observed, for example, you experimented with some setup, you got some results. Okay, you are showing that graph. It is very impressive, perfect. But in addition, you should show the limitations. Like when I experimented with, at some point of time, I got this many weird results. So why? Because why I got that result? That also you are explaining. Okay, so this shows that you are really genuine in your results. Okay, which the reviewers as well as editors are very very interested to know. Okay, remember, PhD is not not something like hard and fast. Okay, it is something that that checks the genuinity, that checks the behavior of a particular person, and therefore don't attempt for some shortcut methods. Okay. Uh, Shortcut methods, of course, some uh, people would attempt to do. Okay. Uh, of course, it is not well entertained among the editorial community. Okay. So experimental setup wise, you can explain the setup, demonstrate the findings, and then showcase that your findings are impressive. And finally, the section comes, the conclusions as well as outlooks. So very important point, what you want to see here is this particular section, whatever you have written, should match with abstract as well as the key findings. Okay. So if this is not matching, reviewer also checks this very carefully, and if it is not matching, he is not going to select or accept your article. Okay. Also, in addition, some few outlooks are required, especially for conferences. For conferences, very important, you should show that these are the future directions. Journals also, they expect that. Okay, and references. References also, here also a lot of issues are there, which can get at first level itself, your paper could get rejected if the references are not proper. Okay, some people just keep some references, which we can easily understand that they haven't followed that 3-pass reading approach. Okay, so this means your references are either incomplete, or your references haven't matched properly with the article that you have written. So apart from all your writing, you could use some tools like Grammarly or White Smoke for grammar check. Of course, English problems could evolve. Uh, and some of the tips are like always try to use present tense in the body, and in abstract it is better to use past tense. In each paragraph, it is better to express one point. Okay. Um, and it is very very important that you should avoid complex sentences as well as words. Avoid to use passive voice. Okay, passive voice means like uh, have been complete. Sorry, what is that? Is to be completed. Okay, uh, like that and all. I complete. That is a simple active way of explaining. So like that. So you can avoid that and all. Avoid extra. Okay. Also, that is if possible. Um, and abstracts and conclusions never write references. Repeated checking is required for spell check and grammar. If you have done lot of works and finally if the spell mistake or grammar mistakes are there, that also creates a negative mark where it doesn't even go to the review process. Okay. And also the figures, if the figures at the end it is stretched or it is not proper, then again it is not going to help. So yeah, the reviewing stages are something like this. Author submitted the article, and editorial office, assess that based on the scope, based on the English, based on the content, and so on at one pass level of reading, and immediately it can get rejected, or otherwise it goes to the reviewers, and now the reviewers will use at least three pass level reading. Where they virtually evaluate whether it is experimentable or the similar works they would have done, so they can easily evaluate, and accordingly they are reviewing, and finally it goes to the editor for final accept, and then it is accepted or rejected. So yeah, when you see as a reviewer's perspective, normally you should notice that the degree of significance is there. Okay, uh, you should also cross check whether the methodology is correct or not. You yourself should read, and you should also give to some expert like supervisors or someone else and read. Check any flaws are identified. If something is there, immediately you should rectify. Okay, otherwise, it is going to the journal office. It is staying there for 6 months, and then again you are getting the same comment. And instead of blocking your paper for 6 months, it is better always to get advice from the supervisors and get all the comments corrected and complete that. Okay. Yeah, degree of significance of results as well as English. Uh, can you understand first of all? Okay, that's how a reviewer will look. Okay, does the abstract describe what you read? Okay, that also a reviewer will look into that aspect. Okay, whether the introduction as well as the conclusion tell the story of story by their own. So I'm reading it, and I should get some real picture of what you are already doing. So from introduction as well as conclusions. Okay, that a reviewer will normally check. Is format same to the journal as well as conference? This also a reviewer will check. Okay, whether the diagrams as well as figures are readable. Okay? Like some people normally write figures with font size like 10 or less than that. It is not readable. Okay, some people write larger. That is also not good. So whether that is perfect, that also a reviewer will look, and as well as whether the references are fully formed. Okay, that is also very important. So the reviewer is evaluating in this angle, and based on that, the review comments are submitted, and you are why where the failure happens. Typically, poor time management. You already did lot of survey, and you already did some experiments, and you are having the results, everything. Then why you are waiting for writing? Okay, um, could do it immediately. Okay, so you should have a proper timeline. Okay, and second issue could be that you don't have a proper network of or a team of people who are working in the same field connected each other. Then the speed up of writing or speed up of becoming productive also affects. Okay, so for example, if you want to write an article and if you are not connected to the right team of people, you are slowing down the research. Okay, then sometimes you may not use the proper writing tools. Like for example, if you are not strong in latex or or some such kind of programmatic related tools, it becomes a problem to scale it to multiple conferences or journals. Okay, so if it is failed, that's all. You spend at least 3-4 days to again format into the another format. So rather you apply or use some writing tools, choose some good English editing processes also, um, as well as planning. Very good planning is required, and if of course if the knowledge the subject is not good, if you are not doing the first step properly, definitely the writing process will end up with troubles. Okay, so um, I think I am in the end. So thank you very much for patiently listening to the talk. Of course, it's a lengthy lecture too, right? Uh, Writing article is, again, I'm repeatedly saying, it's an art. Okay, um, constantly if you are practicing, initially it may take say 5 months or 6 months, sometimes for some people. If you are guided by some supervisors, it can lead to say uh, 1 week or less than that. Okay, so it is dependent on the team who are involved in that writing process. Okay, so I thank you once again, and let me also wish all the best. If any kind of support is all required, you still could uh, share it with us. Yeah, can you please share a sample article which is in this format? Yes, surely I can share one of the article. Uh, which format? Typically, there are several formats. Actually, IEEE format is there. IEEE itself, conference or journal articles are there. Magazine has its own formatting. Okay, so I think you can discuss with me, write to me also. I can share the appropriate analytics. Okay. Thank you so much. If someone wants to jointly write some articles also, let us see how it is possible. If it is possible, I will definitely look into that aspect. Thank you. Thank you so much. Over to, yeah, Mr. Harish. Tell me.
Sir, can you tell about the center, ACM, IIT Kotam?
Yeah. Very important. Thank you. So AIC IIIT Kottayam is an incubation center funded from or supported by Atal Innovation Mission. Okay, so there are like 60, 62 some AICs functioning throughout India. One incubation center is available here at IIIT Kottayam. We are focusing on IoT, cloud, and these kind of product-related developments. Okay, so in addition, we also have MSME Incubation Center, which is funded from MSME industry. Uh, these two incubation centers are offering support to researchers in the form of like, for example, if you have developed some product, or if you are willing to develop a product, you have some idea, you are willing to develop some product. So in that case, we are supporting them. We are promoting basically private limited companies to move to the next level. I mean, the scaling level and so on. So we have a team of people here. CEO is CEO Mr. Nigo, and the community manager is Teresa, are writing this process properly. Okay. So if you have any kind of ideas and some schemes normally pop up now and then, can be in touch with our team members so that we will help you develop the product and complete the product. Any other questions? Okay, now go to stopping my screen. Over to the team. Okay, thank you so much. Yeah, Teresa is.
Thank you all for joining the workshop. It was a great time sparing with you all. Hope to see you all soon for the next workshop. Great day, everyone.
Bye.
We all can log off now, I guess.